for this video, let's try to identify the reflection of point 3, 2 about the angle 45 degrees. I have here Cartesian plane, and we are going to verify the result later on our formula using our Cartesian plane or the graph in this plane, so that we could actually connect it with some concepts necessary to understand this item. So if we're going to plot the 3, 2 at our Cartesian plane, considering that each grid is 1, so you have 1, 2, 3, 1, and 2. This is we can find the 3 and 2. And we are going to take its reflection along the angle 45 degrees. Now, if we're going to come up with a line representing that tilt as we move from counterclockwise, just like in the unit circle, our 45 degrees is presumably somewhere here. Again, assuming that my graph is accurate. Okay, so if my graph is accurate, this would mean this tilt here is 45 degrees. That's for our theta. So we're just simply going to reflect this along this line. So somewhere the point is somewhere here. Okay, a reflection to that. Okay, so it should be on the first quadrant as well, both positive for x and y. So let's try to verify that using the formula. And this time, let's use the formula here for the reflection of a certain point x along the line of our angle. This is identified as the product of two matrices. You have here cosine 2 theta, sine 2 theta, sine 2 theta, and negative cosine of 2 theta times your components of your x, point x. Take note, this is defined because if you have a 2 by 2 matrix times 2 by 1 matrix, the result is also 2 by 1 matrix, which would stand as a point as well. So plugging in here, provided that our theta is 45 degrees and our x has components of 3 and 2, so we will have here this form: cosine of 2 times 45 degrees, sine, let me rewrite that for a better explanation. Cosine twice of 45 degrees, sine twice of 45 degrees, sine twice of 45 degrees, and negative cosine twice of 45 degrees, to be multiplied with 3 and 2 as the components for your x. So take note, when you try to multiply matrices, it would be this row times this column, and that's for the first component, and then we have here this row times that column again. Okay, this would be a review on your matrices as well. So you will have here, you can still simplify first here: cosine 90 degrees, sine 90 degrees. Let's try to simplify our matrix with trigonometric functions, because it will be easier for us to use scalar numbers later on. 3 and 2. So the cosine 90, we know that to be 0. Sine 90 is 1, right? Sine 90 is also 1. This is negative of 0, or simply 0. You have here 3 and 2. So basically you have here 0, 1, 1, 0, and then you have 3 and 2. So for the reflection of your x along the line of your angle, you will have here 0 times 3. Okay. May I direct the result, not show the step-by-step process? So we have here 0 times 3 is actually 0, plus you will have here for your first component, that's 2 by 1, right? Okay. Sorry for that. It's a 2 by 1 matrix. Erase. Let me do it again. It's a 2 by 1 matrix. So 0 times 3 is 0, plus 1 times 2 is actually 2. The other one, 1 times 3 is 3, plus 0 times 2 is 0. So your reflection along 45 degrees is at 2 and 3. It's in the first quadrant. So plotting that here, again, this corresponds to a point at 2, 3. Okay, so 2 and 3. So you have here 2 and 3. Yes, this is the reflection, obviously, since it's 45 degrees. The reflection of 3 and 2 along the line of your angle. So basically, our answer here is correct for the process. So we simply apply the formula to solve the reflection. Okay, so hopefully it's clear for this example. Thank you very much for watching.